Hey y'all, so I thought I'd do something a little different with this lecture because I did give you the PowerPoints, but I did see some things popping up that I kind of wanted to go over. So I'm actually going to record more of the coding screen. I'm going to leave my camera off because we just can't fit everything in one window. And I'm going to put the slides down here in the bottom corner. You already have access to the slides, so if you want to see something bigger or up close, go ahead and just download it and find it yourself. So in this class, we are going to use an IDE. Excuse me, we are going to use Dev C++. I put the bookmark to the correct one. Make sure you get 5.11. That's the latest and greatest. I got mine off of SourceForge, so that was easy as enough. Now, in order to get started in Dev C++, there's a few icons on here, but let's go ahead and keep with the menu bar at first so that we can see what the actual icons mean. If I go up to File and New, and I can click I can create either just a source file or a project. So for most of our work in this course, doing just a source is going to be sufficient. So this is where you're going to do all of your programming, and we're actually going to go ahead and jump in with a short program. First, I want to know, as I usually do, we are in chapter 2, so we're just going to be getting used to using the C and using the C environment. So here I've got just a simple program. It's kind of like the quote-unquote hello world program, but in our book they call it a pun. So for the first thing we're going to type is a hashtag include, and then we're going to use I usually call them pointed brackets, but it's kind of like the greater than and less than sign, and within it we put stdio.h. Now, all of the pieces of this, we're going to get into what all of those little points mean here in a minute. C does ignore white space, so white space is primarily for the programmers and for those that come after it, so you can put blank lines, makes it easier to read, things like that. So next we're going to type in int main void. The nice thing about using the IDE is that a lot of times when you put an opening bracket, an opening parenthesis, an opening less than sign, it will actually put the close there for you. You just have to be careful you don't put an extra close, which I usually end up doing. So let's go to the end of that, and then we're going to put our curly brackets. You can see in the IDE some of the other nice things is that it does group things together. It does put indents, which are the industry typical of what goes on within the code. Now we're going to type a printf, and we're going to say to C or not to C. That is the question. Okay. We're going to put a semicolon at the end, put an enter, we're going to put return 0. Now, a couple things to notice is the colors in the IDE. It makes it very easy to differentiate between what different parts are. So as you can see on my line 5, you can see that there is blue. The blue is within the double quotes, and I was going to see if I can zoom in a little bit. Not really, huh? Let's see. There we go. On my line 5, you can see the blue. The blue is within the double quotes. That means that it is a string. Okay, so a lot of times if you forget to put a quote, the nice thing is that you can see the whole line ends up being blue, and I can kind of visually see very quickly that something is wrong. Some other things, it does that hashtag on line 1, it is going to be green, and all of the markings such as the parentheses, the semicolons, the brackets, they're all red. So it is a little bit easier to kind of match things up and to make sure that they're there. One of the biggest things within C that people usually forget to do is put that semicolon at the end. So having it red really does a good indicator that, hey, it's there, I can see it. Now, what I'm going to do is I'm going to save this file, and again, I'm going to go ahead and use the menu for a little while until we get used to what the icons are. So here I have a save. I'm going to put it somewhere. Let's create a file, CS110. Well, that's not even 110, but that's fine. Okay. What I'm going to do is I'm going to call it pun. Now, Dev C++ does default to saving things as a .cpp or a .cp. Those are the C++ versions. We're primarily going to live within C. So I'm going to go up here and click C source file. Now, most of the time it's not going to cause an issue, but if you do start to have things like some weird syntax issues, just go ahead and make sure that you did save it as a C. If I hit the save button here, it actually puts the file name right here, so I can see very quickly what the file name is. Here we named it pun.c. Okay, the file name doesn't matter, but like it says in the slide, but we do have to put that C in it. Now, I'm not going to go through the compile and linking. I'm also not going to go through in this lecture compiling and linking using a command line, okay? Because in essence, we are going to stay within this IDE environment, which is typical of what you do when you get out in industry. So it makes it a little bit easier. Typically, most businesses have an IDE that they like to use. It does make integration a little bit easier when you have multiple programmers and things like that. So within the IDE, you can code, debug, link, execute, and everything without actually leaving the IDE. So the most general form of any C program is going to be things up here that we call directives, so anything coming before the actual statements. We'll get into what those directives and what a directive is here in a minute. We're going to have an int main void. This is going to be what the computer is going to look for and where it's always going to start. It is a function that is needed in every C program. Okay, you can build other functions, you can name them whatever you want, but you need to have a main function with a small lowercase m. The void in it means you're not sending any arguments to it, and the int means that you're returning an integer. Again, we're going to go through all of this in a lot more detail later on. The next thing that you're going to have on ours, it's on lines 4 and 7, is that you are going to have the curly brackets. That's going to be considered a block of code, and we use curly brackets in C to indicate chunks of code that is grouped together. So within every function, you're going to have a start curly bracket and an end curly bracket. Within those curly brackets, we're going to have statements. Again, those statements are going to be whatever you need the computer to do, whatever those instructions are going to be. So they're going to be as if you are saying a beginning and an end, like when we did our flowcharts. So the three key features that we have are the directives, which in this one is on line 1, the function, which is on line 3, 4, and 7. Okay, you have the function name on 3, you've got the opening and closing brackets on 4 and 7, and then you have the statements. So within the code that we have here up on the screen, 5 and 6 are the statements. Now, let's look at the directives. Before we compile it, we do something called a preprocessor. That was the slide I skipped, so go ahead and take a look at it in the book. And what the preprocessor basically is it is gathering all the information it needs before it does anything else within the program. So, in our example, the hashtag include is going to be something that the preprocessor is going to go look and find. It is going to go find the stdio.h file or library, also called a header, and that's going to contain all of the basic information about the standard input and output library. Okay, the directives are always going to start with a hashtag. There's a few others we're going to learn, but we're always going to use this hashtag include and the standard IO if we're going to print anything to a screen or if we're going to get anything from a user. Okay. By default, they're usually one line. There's no semicolon. There's nothing to end the line. And typically, there is a blank line of white space that is put after it to separate the directives from the rest of the code. Next, remember on line 3, we have the start of a function. So you can create a function. We have user-defined functions. We have built-in functions. Function is going to be nothing more than a series of statements grouped together, typically having a single purpose or a single task, and it is given a name. So library functions are provided as part of the C. That's going to be those functions that are going to be found in that stdio.h. So a function that computes a value is going to always have a return statement. to specify what it's returning. And when we say returning, we just basically mean it gives back something. It would be as if pushing the enter key on your calculator after you put in 2 plus 2. Okay? In the main, we use the return in main to indicate if an error has occurred within the program. So a return of 0 basically means no error has occurred. Now I'm going to switch real quick over into a browser window, and I'm actually going to pull up stdio.h, and we're going to take a quick look at some of the functions that are already built in that we have accessible to us that we can use. Okay, so I've gone over to c++.com, and I actually put the URL for this in our e-learning under references for week 1. In here you can find all of the C libraries and within it what kind of functions they have. So in this I've pulled up the stdio, std for standard, I for input, O for output, and .h because it is a header. So I can read in here output operations can also be performed in C++ using the C standard input and output libraries. And you can see here that they have bolded why it says stdio. Okay, so it's not studio, it's stdio. Some things that you can scroll down here and you can find all of the functions. Now, operations on files, file access, formatted input and output. So they have it grouped together by what you actually would like to do. Now, what we did is we did a printf. So printf here is a print formatted data to std out, which let's think, std standard output. Let's click on printf and let's see what it actually says. So it says it writes the C string pointed by format to the standard output. Ha! If format includes format specifiers, then it basically uses those specifiers. Now here's what the specifiers can be and what they mean. Here is some description of some flags, the width, the precision if you want to put precision, but it has all of the information, including towards the end some examples of what goes on and how it's used. So if you ever have a code that imports a header of a .h of some sort, you can always come to this resource or just Google C headers, and you can find many different websites out there that have this type of information. Now let's get back to our code. As I said before, the main is going to be mandatory. It's special. It is going to be automatically done and executed when you run that program. Any other function, what you actually have to do is call the function and tell the function to run. Main doesn't need to do that. That main is going to return some type of status code, which is going to be an integer, and a 0 again means that it had a normal termination, and typically it'll return a different integer if something went wrong. A lot of times those integers will mean something. We're going to get into that much later in this course. If there is no return at the end of the main, some compilers may produce a warning. This is one of the little slightly differences between C and C++. Typically C doesn't necessarily need those returns, but C++ does. So we're going to go ahead and get into the habit of putting those returns in now, and that's going to help us down the road. The next thing we're going to look at is the statements, and in this example that is numbers 5 and 6, and that is any command that you're going to execute when the program runs. So in this, it only uses two kinds of statements. One is the return, which we already talked about, and the other one is called a function call. Now remember, I said functions, in order to use them, you have to call them. Well, that printf, we just looked at it in stdio.h. It's a function within that header. Okay, so the asking function is going to call another function. Okay, so this code that we have here, this pun.c, it calls the printf to display the string to see or not to see. That is the question. So that is the string that's being sent to that function. Now, C is going to require that all these functions end in a semicolon, and I had already alluded to that, and that one of the biggest errors that students find, and even professional programmers, is that you forgot a semicolon. Again, the nice thing about using an IDE is typically they will highlight them so it's very easy to see. Now, the one exception that we have is a compound statement. We'll see a few other exceptions as we go through this course. And don't forget that directive up there at line 1 does not require any semicolon. So anything between brackets in that block of code is going to require a semicolon at the end. Okay, so that's really the big difference. Now, the printf is going to display a literal string in this case. So a literal string means that anything I put within those double quotation marks, it's going to print out and not do anything with. It's just going to spit it out. So it doesn't actually show the quotation marks. It's just going to show within it. Printf does not automatically go to the next output line when it finishes printing. Okay, so in order to allow it to go to the next line, we use this character you can find here at the end called a /n. The /n is called a new line character, and you need that in order to go to the next line. So let's actually go up here to execute. Let's hit a compile and run. You'll see some information. Let me drag my output screen over here. What you can see here is that it printed out to C or not to C. That is the question. It just put it on a line, and there is a new line, and then it stopped. Okay, here on the output line you can see it had a return value of 0, so you know it executed properly. And in order to get rid of this, you can just hit any key and that screen will disappear. So let's go ahead and change this into actually two different printf statements. So let's say to C or not to C, let's put the quote there. Let's end it and put a semicolon, and then on line 6 let's add a printf that says that. Now remember, white space doesn't mean anything, so I can leave that extra line there. And then let's add a third line here and say printf /n /n. Okay, missing my semicolon at the end. You know what I'm going to do? I'm going to delete the semicolon. I'm actually going to run this so that you can see what it looks like when you have an error. So here, I know I can't increase the font on the bottom, but I apologize. Down here, you are going to have your errors. They're all going to be listing under here, under compiler. The nice thing about the errors is that it's going to give you some information that you can go and look. So here on line 8, it's saying that it expects a semicolon before the return. So I can look here and say return, it's going to expect a semicolon. That's where I missed it. Okay, so there are some clues in here if you have syntax errors as to what those clues are going to be, and it does kind of drive you into where it is. Now, expected semicolon, that always means that you've missed a semicolon on a line somewhere, so it typically takes you to the general area, but sometimes you have to be a little bit more investigative to find out which line it actually is. I'm going to go ahead and compile and run this again. And here, let's see what the difference is. So to C or not to C, that is the question, new line. That is exactly what we did before. So now on lines 5 and 6, we did exactly what we did with line 5 by itself previously. Now we also added line 7. There is a new line here in the middle. So what it should do is it should say brevity is the soul of wit, new line, and then Shakespeare underneath it. That's exactly what happened here. So you can see you can use those /n's, and you need to use those /n's if you use the printf statement. Let's go ahead and press any key to continue and get rid of that, and we can move on. I'm going to go ahead and add some white space in different places because we are getting ready to learn how to comment. So a comment in C is going to begin with a /* and end with a /*. So I can actually come up here and do /*. Look how it turns everything blue. The nice thing again about using these IDEs is that when everything turns blue, it means it's all a comment. So this is a comment. Now if I put a star slash, it changes. So everything that's now in blue is the comment, right, which would be all of line 3, and then everything else goes back into the black and red and blue. So comments can be absolutely anywhere within a program. You can put them on separate lines, you can put them on the same line. Just remember you put the star slash. Typical comments that I'm going to require for this course is name, okay, let's put a, there we go. Let's see, file name. There we go. Purpose. And we can leave it at that. Okay. So the biggest thing that you have to comment is going to be your name, the file name, and the assignment is what I'm going to ask you guys to do. You can do it on a multi-line like I have here at the very top, after your directives, and it will be there. You can even cut and paste between different files as we get going. But comments, again, they can extend over more than one line. It's going to look for this set of slash star star slash, and everything within it is going to be a comment. Remember, comments are completely ignored by the computer system. It is used for programmers. It is used for those looking at your code afterwards. Now you can also put comments after or within a line that has already some statements in it. So if we come over here, I can add a star slash and say forgot to close this comment. Okay. If I come down here and say, and I do like that, so it's ends here, star slash. Okay. One thing that we can see is that even though I have a start and a start, it goes from the outermost start to the outermost finish. Okay, that is a good way to comment out some code that you're not terribly sure if it's working. You can comment out several lines of code at once. So if I say I want to start here, it will then comment out that. If I want to say I want it to stop here, that's not what I wanted to do. I wanted it to stop here. Okay, you have to get rid of the other end. Okay, the starts it'll ignore, the end it won't. So let's get rid of a bunch of these because I just commented out like my entire program. There we go, all gone. So what you can do here is you can do something like prints on line 1. Oops. Nope. There we go. Prints on line 1. I'm not doing well with my shift key today. And if I go ahead and I hit execute and compile and run, nothing is going to change. It's going to run completely the same way it does because it ignores lines 3 through 5, and then it will also ignore the comments on 10 and 11. So nothing changes. So just so that you know. Next thing on our list to discuss today is variables and assignments. So variables are the same regardless of what language you're in. So they basically are just a way to reference a value by using a word. So in case that value changes, you can just always refer to the word and always get the correct value. Now, this is basically temporary, and once your program finishes completing, the memory space that it actually takes up is released back to the system. These storage locations and the words that we give it are called variables. Each variable has to have a specific type, and in C we've got various different types. A lot of them are the same as what you would see in something as Java or Python. We've got types int, which is an integer or a whole number, and float, which typically is a decimal number. A variable of float has a much larger range of storage than an int does. And again, float, decimal point. The drawbacks of float variables are, since the variables themselves are larger and take up more memory space, it is a little slower to do arithmetic operations. And most of the times, as with any decimal, it is an approximation. And so a float may be just that, an approximation. Now, before you actually use any of these variables, you have to tell the computer, like, hey, I'm going to be using this word and I'm going to mean this. That's called a declared. So you have to declare all your variables before you use them. So let's go back into our program. We'll declare a few variables in here to do some practice. So I'm actually going, that didn't work, there we go. I'm actually going to go ahead and put a comment in there saying, hey, I'm going to declare all my variables in this little section, and then this is where my statements are going to begin. Okay, having a problem again with that shift button. Okay, in here you can declare variables in a few different ways. You can declare one variable on each line. So if I have an integer that is a height, and an integer that is a length, and an integer that is a width, and an integer that is a volume, I can do that. I can also, remember, white space doesn't matter, I can also declare some floaters, so profit and float loss. This is a proper way to do it. There's nothing wrong with this. This is actually kind of nice because you can add your comments to the end and you say height of cube. Okay, so you can actually add those comments to give a little bit more information as to what your variables are. We like to try to make variables as self-explanatory as possible. Sometimes that's not possible. The next way that to declare a variable would be to do so all on one line. So let's get rid of that and let's do an int. So we had a whole bunch of ints. Now what we could do is just say the word int once and then put all of the variables with a comma in between. So height, length, width, and volume. Oh, not volume in, volume. There we go. We can do the same thing with the float. Okay. Those two things I did mean identical. They do the exact same thing. There is no difference in them. It's just however you feel comfortable doing it. Now, technically, when you put your variables in your main, or any function for that matter, it is good programming practice to put all of the variables together, grouped together at the very top of the function right when the function starts. So you would have the function name like we have on line 7, the curly bracket on line 8, and then we would start to declare our variables just like I have in this example. Okay, now the biggest thing that you do need to know is whether you do it all out the top or do it whenever, you have to declare a variable before you use it. That's the main thing. Now again, like I said, good programming practice means we're going to put all those variables at the top like I did on 9, 10, and 11, and then go into your arithmetic. So if I came down to the bottom and I decided I needed a new variable, I would go ahead and scroll to the top and add it, and then come back to the bottom where I was and use it. Assignment variables. So this is a way to give a variable a value. So let's get rid of some of these from that old code that we were using. So what you can do is you can give it a value for it to start out with. So a variable is nothing more than a memory location, and if you're not careful, there could be junk in there from an old program that no longer needed that memory location. So what you do is you can assign a variable a value. So here I have already declared height, so I'm going to go ahead and use it. Height equals 8. Okay, as easy as it sounds, an assignment statement uses a single equal sign. Okay, we say that this number here that we gave it 8 is a constant because it's always going to be 8. It's never going to change, so it's not changing variable, which is what the word does. It is said to be a constant. Okay, so you have to declare it, and it is good programming practice again to give it an initial assigned value. Now a float is, again, typically that decimal point. So here height was an int, so we gave it a whole number of the word 8. Let's say we have profit here is a float, and we're going to give it a value of 2,150 and .48. Okay, so it's identical to the way we assigned the integer, except it's going to have that decimal point in it. Now, we can also put an F at the end here to indicate that it's a float. It's not always necessary. Sometimes it is necessary if, say, for example, we want to say 2150 and we don't want to put the decimal place, we can put the F, or I typically just put a .0 at the end. I know it doesn't mean anything, but you are being very explicit then that this variable is to have a float or decimal in it. Okay, now when you start mixing variables, it's a little bit wonky and a little bit strange. So if you have, like I said, for example, profit, which is a float, and I want to assign, 8 to it, and I don't put a decimal point, it's not always concrete as to what's going to happen. So the best thing and the best practice is to just be as explicit as possible. Now, once you have done the assignment statements in here, I'm going to go ahead and do length equals 12, width equals 10. Once I have given them values, I can actually do any type of mathematical function that I want to with them. So now I can calculate a volume by saying height times, which is the little star, length times width. Okay? What that's going to do is that is going to multiply. So it's going to give you 8 times 12 times 10. There we go. Okay. So now the right side of this, where I actually have the equation, that is called an expression. Same thing as a formula. Formula, expression, they mean the same thing. Typically, it's going to involve constants, where I could say 8 times height, variables, and the different operators like addition, subtraction, multiplication, division, things like that. Now I can go back and use my printf to print out what I calculated. So let's say height, and I'm going to put the height in there. Now, in order for printf to understand that I want it to have a variable, I have to give it a little placeholder. So a % is the placeholder for a variable. In order to do an int, I do a D. Not really sure why a D, never made sense to me. I'm going to do a new line after that. I'm going to come outside the quotes and put a comma. Now, because I put that placeholder for a variable of that %d into that string, I then have to give it the variable that I want to put in there. So let's say height. Now, if I run this, execute, compile, and run, it's going to give me the output of height 8. Okay? Now, if I want to get, now if by contrast I want to output a float, I can say, let's see, profit. I didn't leave my profit here, I deleted it. So I can put profit here, change the D to an F for float, and print out profit. Compile and run. So now one thing to notice is because float is a decimal point, even though I said 0.48, it actually gave it a value of 0.79980. That's why I said you have to be a little careful when you're talking about the decimals. Now, if I want it to look better, so say I want this profit to be a monetary amount. So I can actually come in here and before the % sign, which is that holder, put the $sign. Now, between the $sign and the F, I can indicate how many decimal places I want. So since I'm looking at money, I want 2 decimal places for the cents. So if all I do is change and put the $sign there and the 0.2, let's see what that looks like. So now it has printed out to be 2150.48. That's much more what we're used to seeing, and it's much more pleasing to the eye. Now, you can put as many variables in a printf as you want. Just know that when you start listing them after the comma, you're going to have to list them left to right. So let's go ahead and put back in height and do %d. Okay, let's put some spaces, length, %d, and then we can put our /n. Now remember, left to right after the comma, so the first thing I want is height, and then I want length. So I can stack them in this way so that you can end up putting multiple variables on one line and in one string. It works out pretty good. Now, in the book, it goes through an example, and we can look at that example here. Let's get a brand new file, new source file, and I'm going to save it as example 1. Remember, select C source file, and I'm ready to go. First things first, hashtag include stdio.h. Okay, int main void open close parentheses. Oops, if I can spell return right. Okay. Now, if we remember our steps, we want to declare first, declare variables. Then I want to do my statements. There we go. Now, as you can see here, what we're going to try and do is write a program to compute the dimensional weight of a box. So shipping companies charge extra for boxes that are large but light. The usual method is the dimensional weight to divide the volume by 166. So they're going to call it a dweight.c program. It's going to compute the dimensional weight of a particular box, and that is what a sample output is going to look like. This is typical of what we're going to see as far as lab assignments go and class assignments. You'll get some information about an input, and then you'll have an example output. So in C, you represent division by using a slash. The other thing to note is that if you have integers and you divide integers by integers, it is actually going to truncate. It doesn't round. It just ignores everything after the decimal point. So there are a few things that we can do in order to correct that. So one solution is to add some information to it so that you're always going to round up. And some other ways of doing it is actually to create them all in floats, and then you don't have to worry about that truncation. So let's look here at the code for doing this. So we're going to have some integer values. We're going to have height, length, width, volume, again with the N, and weight. Okay. That's going to be our first set of variables. Now let's give them all values. So height equals 8, length equals 12, width equals 10. Okay, now let's go into our statements. What we're going to do first is we're going to calculate the volume. So the volume is going to be equal to height times length times width. And then our weight is going to be equal to volume, and we're going to do it the way that the book does it first. So volume, there we go, plus 165 divided by 166. Okay. then we want to print out those values. So these values are going to be hard-coded. We're not asking the user at this point. We are just assigning those numbers. So our first printf says dimensions, and then %d times %d times, which is what the x is standing for, okay? So technically I could do star, %d star, that's not a star, star %d /n, okay? At the end of that, we're going to put length, ng, man, my spelling today is terrible, height, width, height. Okay. Now we're going to print the volume. Printf volume, oh my, cubic inches, %d /n, outside, comma, and what do we want to put in there? We want to put in volume. Okay. Our last printf is going to have dimensional weight, oops, in pounds. We want a %d and a /n, and then we want it to give weight. Okay. Let's go ahead and do an execute, compile, and run. So here is our output. Dimensions equals 12 times 10 times 8. Or like I said, in the book, they actually use an x, but to me it's a little confusing because it looks like %dx. It's not what it is. They mean for it to be a multiplication symbol. Your volume in cubic inches is 960, and the dimensional weight in pounds is 6. Now, some variables are automatically set to 0, but most of the time they're not. So this is what we talked about before about giving them this initial value. Here we did it in lines 8, 9, and 10. Now, if we say it does not have a default value, it is uninitialized, and that can access some memory that you just don't know what's in there. So it's always good to initialize your variables before using them. So when we do that, like on lines 8, 9, and 10, 8 is said to be an initializer. It is the initial value. Okay. The other way, you can actually do it all in one line up here. So I could actually say 8 up here, length equals 12 up here, and width equals 10 up here. And this is actually identical to what we had before. Okay, so you can put it in either place. This right here, it is not going to initialize volume or weight. I can show you, but it does not change the output in any way, shape, or form. Volume and weight just are not initialized. Only height, length, and width are. Printf can also actually do some calculations. So if you don't want to create another variable like we have on line 9, we can actually type it in here. Height times length times width. If I go ahead and run and compile, again, I have, oops, there we go. I have the same value of 960. So this is going to give you the same information as if I put the variable name volume. You can do it either way. Now, we're going to learn, I'm going to put let me put this back to volume. There we go. Now, we're going to learn how to get our user input. This is going to be the partner to printf, and it's called a scanf. So in order to use scanf, it requires a format string, just as if printf does in this manner, like on 12, 13, and 14 with that %. So it knows what it's going to get. So I'm going to put in here some input statements. Okay, so what I can do is I use the word scanf, Okay, I put in the quotes. I'm going to put in there the percent sign as the placeholder, and then what I have to do is place in there the type of variable that you're expecting to see. So if I put a %d in here, it's going to expect to see an integer. If I put a %f, it is going to expect to see a float. Now, the only other added caveat, as you can see here when in the pull down, is you're going to put a comma after the double quotes. You need to put the ampersand sign, which is above the 7, and then you put a variable name as to what you want, where you want to store that number. So if I put height here, that means whatever is typed in on that line, I'm going to store inside the variable height. That's how I like to think of it. Okay, the ampersand is actually a pointer, which we are not getting to in this class. That will be advanced programming, but for our references, all we need to know is that take that information and put it into that variable. We can read this by saying that you're going to read in an integer and store it into height. Now, the book uses I already had height up here, so it's fine. If I want to read a float, again, I can just put a %f in there, and everything else just remains the same. What's going to change is the indicator of the type of that you're expecting to have in that input. So let's take our example 1 and let's expand it. So instead of saying height equals 8, length equals 12, width equals 10, let's ask the user what we want for those numbers. Now, when you ask the user to input something, it's always a good idea to give them something called a prompt. And the display prompt is going to tell them what you are expecting to see. So, for example, this first scanf, let's go in front of the scanf and let's put a printf for the prompt. Let's say enter the height of the box. Okay, then I have the scanf and the %d because we've got it as an int up here, and height. Let's do printf, enter the length of box. Now notice one thing we're not doing, we're not putting these /n's because we want the cursor to wait at the end of this until the user presses the enter key. So that will keep it all on the same line. Scanf, %d, outside, no 0, ampersand, length. And the last one, enter the width of box. %d, comma, width. Now, I've left everything else identical. I left my output identical. Let's see what happens when I run this. Now, I know I said I was going to use the words, but I'm going to go ahead and use this one right here, which is the compile and the run. One thing I want to point out too also with this IDE, so if these icons are colored in, it means it has not saved. Another example that you can see is the asterisk in front of the file name. So I know that this has not been saved. Now, if I use this compile and run, as you can see, those go dark and the asterisk goes away. Okay, let me move my screen over here. So now it's asking me for a height of a box. Let's say I've got a box that's 1 by 1 by 1. Now, I don't want to put in the 8 and the 10 and the 12 that we had before because we have those assignments in here and I won't know if it's changed. So I'm going to do 1, 1, 1. 1 times 1 times 1 is 1. So I got that. So see, dimensions of 1 times 1 times 1. My volume is 1 and my weight is 1 pound. Easy peasy. So you can see how it took these numbers, overwrote what I had given it here because it came after it. Okay. Again, nothing changed in lines 16 through 24. The only change we did was right here through 8 through 14. Now, one thing we have not talked about yet is constants. So we do have a number here of 166. We could actually put that constant somewhere else and use a word for that constant, just like we would as if it were a variable. So we can actually call something called inches per pound. Now this is going to go up into the directives, okay, because it's going to have a hashtag, but then this time instead of saying include, we're going to say define. Okay, what that means is you are defining this constant. Convention says constants are going to be completely all in caps, so I can say inches per pound. There is no assignment statement, there's no equal sign, and I just put the number here. Okay. Now I can come down, and I'm lazy, so I'm going to cut and paste, copy, and here actually put inches per pound and inches per pound minus 1. Okay. Again, it's going to give the exact same information. Okay. It's just here, instead of putting 165 and 166, we're using that constant. Now, the preprocessor is going to basically take whenever it sees this and replace it with this number. Okay. They call it a macro. It's not to me a macro. A macro in my brain it means it wants to do something, but it kind of works in the same convention. Now you can do an expression like it shows in the slides. Here we've got like a reciprocal of pi. So if you do that though, you do need to put parentheses, and that way it knows that it has to do something within those parentheses. Here, there's another example of another program. This is converting Fahrenheit to Celsius. I'm not going to go through that one. You can go through that if you would like to. I'm going to do a little bit of a switch here for us because there's not too much more to do with actual programming, but there's a lot of more information that we know here. So here, we use a term for variables. The names that we call variables, we actually call them identifiers. So it is identifying the variable, or identifying the function, or identifying the macro. So if I say an identifier, I mean the actual words. Any identifier can contain letters, digits, and underscores, but it must begin with a letter or an underscore. It's usually, we don't usually, and I don't personally like underscores at all. I will do a mixture of a lowercase and capital. Convention tells you that all functions and variables will start with a lowercase letter as well. An uppercase letter means something completely different when we're talking programming convention, and we'll be talking about that later as well. So some examples of some illegal is by putting a name, a numeric in front. So that first one, it's 10 times, that is illegal. The next illegal is to have a dash. The only character symbol that is acceptable within C variables is the underscore. It is case sensitive, okay? So C does distinguish between uppercase and lowercase. So for example, all of those are completely different identifiers. So you've got lowercase, all lowercase JOB, capital B, capital O, capital J, capital OB. Any one of those combinations means something different. They're all completely different identifiers for different variables. Again, most of the times, many programmers will only use lowercase with underscores unless it is one of those constants or those macros, and then those would be completely uppercase. I tend to fall in that second realm where I like the uppercase letter to begin the next word if I need to concatenate words. My brain somehow works a little bit better with that second convention than it does with the underscores. I'm not a fan of underscores. There is also no limit on the number of characters you would like to use when you're looking at an identifier. The only caveat with identifiers is that it cannot be a keyword. Okay, now remember, and this trips up a lot of people, it is case sensitive. So for example, you cannot use the word break, all lowercase, but a capital B break would be okay. Little confusing? I usually just steer clear of all of these. So for example, here we have a lowercase I, lowercase f. A capital I, lowercase f would not be the keyword. The keyword is the all in lowercase. Now, keywords must be written using only lowercase, and names of functions are typically also all in lowercase. When you start an identifier with an uppercase, it typically means that it is a class of some sort, and that's more in the object-oriented world, and that's more we'll be getting into that in advanced programming. So we say that a C program is a series of tokens, and each token is going to be a smaller chunk of the overall program. So it can be an identifier, keyword, operator, punctuation, constant, the string literal. So the statement that we have here that we used just now, the height, it actually has a few different tokens in it, okay? We have the printf, which is the identifier. It has some punctuation. It's got a string within the double quotes. It has more punctuation with the comma. Then it has another identifier for that variable, and then some additional punctuation. So you're basically just building these statements just token by token or piece by piece. Again, C, it just ignores white space. You can put blank lines, you can put extra spaces, it just ignores it. So if you have something like this, code that's on the screen towards the bottom, it's a little bit wonky for your eye to see, it's a little bit hard to differentiate. I like to put blank lines between everything when it kind of changes what it's doing. So I might sometimes put blank lines after the hashtag include, and then another one after the hashtag define. And then definitely here you can see in this main, it's all like in one little section. It's fine, it'll run well, but this is going to be hard for your eye to follow and to debug and make sure you have everything that's all in there. Okay. It's not required for the compiler, it's required for the human sanity. How's that? So it makes it easier to understand, just like having those comments. You can have as many of them as you want. You know, you can also divide longer statements between lines. If you start running off of the screen, you can add, you know, some white space to have it come to the next line, and it'll work just as well. Indenting helps also with your organization of your code, as well as those blank lines. So here, terrible example, but here we go. Right, you don't want to put the spaces between any of the letters of a keyword, but you can put them between keywords or between those tokens like we just talked about. So here you also don't want to put a new line between the keyword, but you could put them after each one of the tokens. Now, you can put a space inside a string, but it's going to change the meaning of the string. The white space within double quotes does mean something. That is going to space out what you are actually displaying on the screen. So one thing here, the example, this is illegal to put a new line. Here they just did a carriage return and put that as the question on the next line. No, you have to put the /n. That's what's going to help you do it. So hopefully that has helped you get through a little bit of the basics of C, and I can't wait to see y'all's labs and programs.